Alright, year 13, as promised, here is your video on the energy systems, and in particular we're going to look tonight at the ATP system and the lactic acid system. So we are not going to cover the aerobic system in this video, that will come later on. Matty, you'll be pleased to know that I've put down the bottom there for you nice and clearly. It is Unit 3 Chapter 1, which will help you with your filing system, which I've discovered is obviously so important to you. So here we are. ATP resynthesis. So this should all be recap stuff like we talked about today, but just so we're all singing from the same hymn sheet, ATP has to be resynthesized to keep us exercising. Remember, ATP is our energy source. That is where we get our energy from, sometimes referred to the energy currency, and it's the breakdown of that gives us energy. Everything we're talking about tonight is designed to give us that energy by recreating ATP. So the three systems that provide us with that ATP are the phosphocreatine system, which is here, lactic acid system, and the aerobic system, which this video isn't going to cover, like I said. It's a coupled reaction, which you'll remember before, so the energy needed from this reaction below is taken from another reaction, and that's where we're going to get to. So ADP, adenosine diphosphate, so it's two phosphates plus another molecule of phosphate plus energy gives us ATP, which is the energy source, and that's an endothermic reaction. Endothermic meaning it takes energy from its surroundings. So hopefully as we move forward, let me just see, that's fairly self-explanatory. So as we move forward, this might make it a little bit clearer. It's fairly basic, and like I said, we are going to work basically in here. Oh, I've got a little sound effect there. And a flash. Woohoo! Right. Adenosine triphosphate. We've got one molecule of adenosine, and then we have our 1, 2, 3 phosphates. The introduction of, I'm trying to make that energy stop flashing at the bottom, but it's not going to. The introduction of this ATPase, and that's an enzyme. Anything ending in ase tells us it's an enzyme. The introduction of NTPase triggers a reaction that provides energy through adenosine and the bond between the phosphate molecule here being broken, which leaves us with adenosine diphosphate. Here's adenosine, here's our 1, 2 molecules of phosphagen, and our other phosphate has been broken off. That bond has been broken, and it's the break in that bond that gives us the energy, the movement energy, and that phosphate is then left. If we then look at how we resynthesize ATP, this is exactly the same as what we had just before. So we're back down here. We've broken that bond to give us energy, and that phosphate is now loose from that molecule of adenosine. The introduction of an enzyme, creatine kinase, to phosphagen gives us phosphocreatine. And the creatine is found in the muscles, and we'll talk about that in a little bit more detail. And that also produces energy, but we're looking again at that endothermic reaction. So this is an exothermic reaction where the energy is created, an endothermic reaction where the energy is used to reattach this phosphagen here to adenosine to give us adenosine triphosphate, 1, 2, 3. So the phosphate that's created through this phosphocreatine being created, so creatine kinase connects the phosphagen to the creatine, and then energy is created as that phosphagen molecule breaks free again and reconnects with our adenosine. If you look at page 12 in your textbook and look at figure 1.5, you will see another version, another diagram that might help you with this, with these coupled reactions. Just looking here again, this might help you a little bit. So phosphocreatine is used to provide the energy to combine our ADP and the 1 molecule of phosphagen that we just saw in the last diagram, and that then gives us ATP. So phosphocreatine is equal to 1 molecule of phosphate, 1 molecule of creatine plus energy, exothermic. It creates energy. That energy is then used alongside ADP to reattach that molecule of phosphate to give us ATP. So and this all takes place in the sarcoplasm, and we're going to talk about creatine a lot later on, but creatine is a term that you've probably heard before. Just some headlines about the ATP system. It produces 1 mole of ATP, 1 measure of ATP, 1 molecule, whatever you want to call it. It doesn't need oxygen, so it's anaerobic, which you'll know. And creatine kinase, that's that A's again on the end for an enzyme, is the enzyme that breaks the PC bond. We carry about 120 grams of creatine. This is just a little bit of background for you. And the repeated breaking down of that PC in order to produce energy is temporary. Alright, it's temporary. You'll know that it only lasts for 10 seconds, and this is used for short bursts of speed. Now why I'm talking about this only being temporary is because it only lasts for 10 seconds, and it doesn't start once our PC stores are depleted, which happens after 10 seconds. We don't have any PC left in the sarcoplasm. That PC doesn't start to be replenished until exercise goes back to submaximal. So if I'm doing the 100 meters, I'd be using my PC system if I'm Usain Bolt for those 10 seconds, and then that I would exhaust those stores of phosphocreatine within that 10 seconds, and then it wouldn't be until I've stopped the 100 meters that I then start to replenish that in the sarcoplasm. Like it says there, it's high intensity, there's no harmful waste products, and it does not need oxygen to work so quickly. That's an advantage. A disadvantage is that we're only getting 1 mole of ATP, and when we go onto the aerobic system you'll see that we get up to 34 moles there, and there's only a small quantity of that phosphocreatine like we talked about in the muscles, so it only lasts for 8 to 10 seconds. This slide's really important. Don't start copying it down. I will give you a copy of that so that you can stick in your textbook, but it basically tells you what the fuel is used, where it takes place, what are the waste products, and I've got one of them for each of the 3 energy systems that you'll find really useful. So we move on to the lactic acid system, and it's really important that you get this right, because basically if you understand this, when we come onto the aerobic system it makes it easier because they just follow on. So it's sometimes referred to anaerobic glycolysis, but the lactic acid system is absolutely fine. Okay, it does not require oxygen to function, so it's anaerobic, and this starts once PC is depleted. So if I'm running 200 meters and my PC systems ran out after 10 seconds, it is then the lactic acid system that takes over to resynthesize ATP, and this comes from the breakdown of glucose, and glucose is how the body stores carbohydrate. Yeah, glycogen and carbohydrate in effect, and we'll talk about that a little bit more in lesson. So glucose is stored in the muscle as glycogen. So glycogen is glucose, and it's in the muscles and in the liver. So when you eat carbohydrates, your body turns that into glycogen to store it. If you've got too much glycogen there that the stores are already full, it then turns those into fats, and that's why you put weight on, which is why some people eat a low carb diet. Just going slightly off topic there, but before the glycogen can be used to make ATP, it has to be converted into glucose, and that's called glycolysis. So glycogen is stored in the muscles and the liver, but to use it we've got to get to glucose, and that's called glycolysis, and that reaction is triggered by glycogen phosphorylase, and that's another enzyme, A's in the end there, so that triggers that. You don't actually need to know that, that's a little bit too detailed. What you need to know is the process is called glycolysis. Alright, basically the glucose molecule then is turned into pyruvic acid, and the enzyme that's responsible for that, and you do need to know that, is phosphofructokinase, PFK. That's the enzyme that triggers that, and during glycolysis we create 2 moles of ATP in this pyruvic acid. Now in the absence of oxygen, so there's anaerobic, there's no oxygen there, that pyruvic acid uses lactate dehydrogenase to turn that into lactic acid, because that's a product that our body can safely store. We can't safely store pyruvic acid, our body can safely store lactic acid. So when there's no oxygen present, we use lactic acid. We store pyruvic acid as lactic acid, and what you'll find when we go into the aerobic system is that when there is oxygen present, we don't create lactic acid, we go into the aerobic system. So 2 molecules are resynthesized. This is up to sort of 3 or 4 minutes, looking at around about 400 meter events, those kind of things, and again we're looking at sarcoplasm. This diagram shows you in a little bit more detail. So you've got this glycogen phosphorylase creating glucose. Remember, glycogen is how we store it. We need it to be glucose to use it. Phosphofructokinase is the enzyme here that creates glucose, and then we get 2 moles of ATP from that, being energy. Byproduct there is pyruvic acid. We use this lactate dehydrogenase as the enzyme that turns things into lactic acid so we can store it. You want to be looking at 1.6 on page 12 to see that diagram as well, if this video is just going a little bit quick for you. Main advantages there: it provides energy for high intensity exercises, like it says. It lasts longer than the ATP system because our glycogen stores are relatively high in comparison to the PC system they are, and it doesn't need oxygen to work, so again it's quick. Disadvantages is that lactic acid, as you'll all know, does cause muscle fatigue. That's the waste product of this system, and it does cause muscle fatigue. Again, take a look at that sheet now, but I have got that in your textbook, but take a look at that now because it'll give you a good overview of where we are with things. And we won't go on to the aerobic system because I don't want to confuse you in this video. I've raced through that. That's 11 minutes of me talking and racing through. I would expect that you're going to need to watch this video at least 2 or 3, if not 4 times. Get your notes down, see which diagram works for you, look at what's in the textbook, read through, compare, listen to what I've been saying. Any questions, email me, and I will see you on Friday where we'll go through that in a little bit more detail, and we'll also look at the aerobic system. Alright, thank you very much.